Hello, Latin geometry students. In this assignment, we're going to talk about the SSS, or side, side, side rule. And we're related back to this toy you remember playing with, hopefully, from kindergarten, called Tinker Toys. Tinker Toys are these little things where they had the sticks, you put them in the wheels and put them together and built assorted shapes. So let's say your teacher gave you these bits of Tinker Toys, these three sticks and the wheels to connect them, and asked you to build a triangle. So you'd run over to the corner and you'd stick it all together and you'd make a triangle out of it. Then, say the teacher found a different kid, say this guy, and gave him the same parts, and that kid also built a triangle. What do we know about these two triangles? Well, the SSS rule says if the three sides in this triangle are the same as the three sides in this triangle, then the triangles have to be the same. Your triangle and the other kid's triangle have to be the exact same thing. So the SSS rule says if the three sides in one triangle are the same as the three sides in another triangle, then the triangles are congruent. This is SSS for side, side, side. The three sides in one and the three sides in the other. So here are some sample geometry problems. What we're looking for here is which pictures are examples of SSS, which pictures show two triangles with all three sides the same. So in this first picture, we want to decide are the three sides in the triangle on the left the same as the three sides in the triangle on the right? Yes, they are. This is an example of SSS. That side matches that side. They have the same marks. This side over here with 2 marks matches this one over here with 2 marks, and the side with 3 marks matches the side with 3 marks. So this is an example of SSS. How about problem number 2? Are the three sides of one triangle the same as the three sides in the other triangle? No. We only have 2 pairs of matching sides. We see this side matches this one, and this side with 2 marks matches this side with 2 marks, but we don't know anything about this side and this side. Now we have an angle mark congruent. These triangles might be the same, but they're not SSS. How about problem number 3? We're looking for are the three sides in one triangle the same as the three sides in the other triangle? No, they're not. In this case, we only know one side over here matches one side over here. We know some things about the angles, but we don't know about the sides being congruent. So these two triangles are not an example of SSS. Finally, the last one here, are the three sides in the triangle on the left the same as the three sides in the triangle on the right? Yes, they are. They have all have the same measures. 5, 6, and 7 for one match 5, 6, and 7 for the other. So that is an example of side, side, side. Once we know two triangles are congruent, we have to state it, and that's where we use those congruency statements. So for these two triangles, we're going to say the triangle on the left is congruent to the triangle on the right. So we name the triangle on the left, and we try to do that as close to alphabetically as we can. In this case, that'll be easy. We can say triangle DEF is congruent to, and then we got to match it up in the triangle on the right. Now, angle D over here is between the side with 1 mark and the side with 3 marks. So we come over here and we find the same matching spot. The angle between the side with 1 mark and 3 marks here would be I. So angle D goes with angle I. Take a moment to figure out what goes for angle E and F. So naming the second triangle in order, we'd have triangle IGH. So triangle DEF is congruent to triangle IGH. Now, shortly, we're going to have to talk about proofs with this, so we'll need to justify this. We need to explain how we know that. But how we know that's really simple. How do I know these two triangles are the same? It's by SSS. SSS would be our reason if this was in a proof. Second problem here. All right, these two triangles are congruent. We already know it's going to be side, side, side. We just have to write our congruency statement. So we're going to name our first triangle as close to alphabetically as we can. That's FGS. Name the second triangle in matching order. All right, so for this one, we're going to say triangle FGS is congruent to triangle RMT. F is in the same place as R, G and M, S and T all go together. If as a proof and you were asked for a reason, how do you know these triangles are congruent? Well, this is because of side, side, side. For these problems, we just want to identify whether each picture is an example of SSS or not. That's it. So in problem number 1, we look at our two triangles. Is this an example of SSS? Yes, it is. The three sides of one triangle match the three sides in the other. All right, for problem number 2, is that one an example of SSS? No, it's not. We do have two sets of sides that are congruent. That side's the same as that one, and this side's the same as this one, but we don't know anything about the sides on the bottom, so it's not SSS. We only had two pairs of congruent sides. All right, problem number 3. Is this an example of SSS? Yes, it is. We have the three sides, 10, 15, and 22, matching the three sides over here, 10, 15, and 22. These triangles would be congruent by SSS. How about number 4? Number 4, these are not an example of SSS. We have two pairs of matching sides. The 22 pairs up to 22. The 18 goes with the 18, but we don't know anything about the left side over here and the right side over here. So these two are not an example of SSS. Okay, the last one is a trick question. You can take a second and see if you can figure out what the answer would be, but it is a trick. See, in this problem, we see that the top is congruent to the bottom, so one pair of sides in the two triangles. The left is congruent to the right. It's another pair of sides in the congruent triangles. But that's it. We don't have a third side. Actually, we do. It's just something we're going to talk about a little bit more later. This side in the middle, DG, it's the same in this triangle on the top as DG is for this triangle on the bottom. This side is the same in both of them, and it's the same because it's actually, when we get to this, this is going to be the reflexive property, saying that this side is congruent to itself. It's a side in both of the triangles. You won't have to do that just yet, but that will be coming. This is an example of side, side, side. All right, the last thing and the most common thing we do with SSS is use it in a proof. See, SSS is a way of proving two triangles are congruent. All the proofs we've done to this point have simply been algebraic proofs, but here is your first full-fledged geometry proof. You'll notice a couple things. One, we're given a picture. There's usually a whole bunch of given information. And then our statements and reasons, in this case, they're set up for us. They won't always be. But we're being asked to prove that two triangles are congruent to each other. There's a whole bunch of different ways you can do a geometry proof, but probably the best thing to do is, number one, make sure you have a picture. And if you don't, draw one. This one came with a picture. That'll make that easy. Number two, start taking the information that you know and marking it in the picture. For example, the first thing we're given is that segment AB is congruent to segment WF. So we go into our picture and we add those tick marks that represent that. Then, next thing we're given, segment BC is congruent to segment WG. So I'm going to go into the picture here and mark those. Again, that's just given information. Finally, go to the third piece of given information. Segment AC is congruent to segment FG. And now we can look at our two triangles. Are these two triangles congruent? That's what we're trying to prove. Yeah, they are, because they have to be congruent because this is an example of SSS. So these two triangles are congruent by SSS. The proof over here is just writing out exactly what we just said here on the left. So the first thing we did when we marked up our pictures is we started with the first piece of given information. We said AB was congruent to WF. For the proof, we're not just putting the marks, but we have to write that out. So the first thing we know is that AB is congruent to WF. How do we know that's true? Well, in this case, it's given to us. The proofs won't always be this easy with so many givens, but this one's got a lot of given in it. The second thing that we knew about these triangles, the second mark we made in the triangles, was that BC was congruent to WG. So that's going to be our second statement. How do we know that was true? That was also given to us. Finally, the third mark we put in the triangles was that segment AC and segment FG are congruent to each other, so that becomes our third line in the proof. The reason for that, yep, it's also given. It won't usually be this much given. And then finally, what conclusion did we draw at the end here? Well, we looked at the two triangles and said these two triangles have to be congruent. And the reason was SSS. That's how we knew these two triangles are congruent. You should note, and this should always be the case, what you're trying to prove is always your last statement in your proof. Remember, what we're trying to prove, this is like the directions. It's like trying to tell us to get to this point. Finally, the last thing we're going to do is make a small change. Instead of trying to prove the triangles are congruent, I'm going to ask you to prove that angle A and angle F are congruent. Well, angle A up here and angle F down here, this is like one of the problems from the other day. We know these two are going to be congruent. These two angles, they're in the same spots in congruent triangles. So since the whole triangle is the same, these corresponding angles also have to be congruent. That's what CPCTC says. So in this case, we've already proven the triangles are congruent. So now we can say any two parts in the triangles, any two corresponding parts in the triangles are congruent, including angle A is congruent to angle F. And the reason for that would be CPCTC.